Types of graphs. Okay, so now we will study how many types of graphs. Okay, so first is isomorphic graphs. So two graphs G1 and G2 are said to be isomorphic if one correspondence between their vertices and edges. Okay, so two graphs G1 V1 E1 and G2 V2 E2 are said to be isomorphic if there exists a one-to-one correspondence, if there exists a one-to-one correspondence between their vertices and their edges. Okay, means a function f from v1 to v2 which is 1 1 and onto. Okay, 1 1 correspondence means 1 1 and onto, and similarly g from g another function from e1 to e2 is also 1 1 and onto. Okay, so 1 1 correspondence means 1 1 and onto. It means if we have two graphs G1 and G2, okay, suppose V1 is equal to small v1, small v2, small v3, okay, and v2 is equal to v1 dash, v2 dash, v3 dash. It means a function f from v1 to v2, this is 1 1 and onto. It means this is v1, v2, v3, and this is v1 dash, v2 dash, v3 dash. So a function this type means v1, v1 dash, v2, v2 dash, v3, v3 dash. So this is 1 1 and onto. And similarly between edges means E is equal to E1, E2, E3 and E1, E2 is equal to E1 dash, E2 dash, E3 dash. So a function g from E1 to E2 which is 1 1 and onto, it means this is E1 and this is E2. So E1, E2, E3, E1 dash, E2 dash, E3 dash. So this is 1 1 onto. Okay, this is 1 1 onto. It means two graphs are said to be isomorphic if their vertices and edges possess the property of 1 1 correspondence. Okay, so now suppose this is a graph, first graph g is equal to g1, first graph is e1 v1 is nothing but this is, suppose this is v1, this is v2, this is v3, this is v4. Okay, and between the edges, these are edges. Okay, between v1 and v2 one is, v1 and V2 to V3 one is, and V2 to V3 another is. If we add V2 to V3, also we can add V1 to V3. Okay, so this is a graph G1 is equal to V1 E1. Okay, so now we need another graph which is 1 1 and 2, means number of vertices are 1 2 3 4. Okay, so in next graph means in G2 is equal to V2 E2. In G2 have also 4 vertices. Okay, so suppose this is V1 dash, this is V2 dash, this is V3 dash. Okay, so V1 to V2 one as, so V1 dash to V2 dash one as. V2 to V3, it means V2 dash to V3 dash. Okay, V3 to V2 and V1 V2, V2 V3, then V3 to, sorry, this is V4, then V1 V3 and V1 dash V3, because V1 V3. Okay, so V1 V2 dash V1 and V3, so V1 dash V3 dash, this is okay. And similarly this is another like V4, so this is V4 dash. Okay, so we add by this is, so this is 1 1 correspondence G2, G1 and G2. It means how many vertices in G1? 4. How many vertices in G2? So 4. And edges between corresponding vertices are same. It means these G1 and G2 are isomorphic. Okay, so this is the definition of isomorphic graph. Similarly, if you want to take very simple example, if suppose this is G1, A, V, C. Okay, this is one graph G1, and now suppose this is A dash, suppose this is B dash, and this is C dash. So these two graphs are isomorphic, means number of edges is equal to number of vertices, both are same. Okay, so this is the definition of 1 1 correspondence. Now I am going another example which is not isomorphic, means two graphs which are not isomorphic. So I am going to explain one very nice example. So suppose this is vertices A, B, this is C, this is D. Okay, and these are another vertices E and F. And another graph we will draw here. Suppose this is A dash, this is B dash, this is C dash, and here this is D dash. Okay, and this is E, this is F dash, E dash, F dash. So number of vertices are same, number of vertices are same, but edges between corresponding vertices are different. So here this is G1 and this is G2. So this, in this case, G1 does not isomorphic to G2. Okay, so between two graph, 1 1 correspondence between their vertices and their edges. If it is possible, then we say two graphs are isomorphic. So next is regular graph. Okay, so second is regular graph. What is regular graph? So, very simple definition of regular graph. A graph is said to be regular if each vertex have same degree. Okay, it means a graph G is equal to VE is called regular graph if all vertices are of equal degree. Okay, so this is called regular graph. It means if here any graph have two vertices v1 and v2. Okay, so this is graph. So v1 has 1 degree and v2 has 1 degree. So this is regular. Next example, if you take this type of graph v1, v2 and v3, means this graph has 3 vertices, means v1, v2, v3. So each vertices has same degree, means degree of v1 is equal to 2, degree of v2 is equal to 2, degree of v3 is equal to 3, because we have know about degree. What is degree? Degree of vertices means number of edges connected to that vertices. How many edges connected this vertex? 2. Here 2. Here 2. So since each vertices has same degree, okay, so this graph is called regular graph. Similarly, if a vertex v1, another vertex v2, another v3 and another v4, okay, so this is v3, this is v4. If we draw a graph, so v1 to v2, v1 to v3, v1 to v4 and this, okay, this is a graph. So in this case, if we draw another, means v1 has 3 degree, so we want to this thing, because v2 has 3 degree, v3 has 3 degree, v4 has 3 degree. It means all vertices have degree 3. It means this is a regular graph. So very simple definition of regular graph. A graph G is equal to VE is called regular graph if all vertices are of equal degree. Okay, so this is a regular graph. Subgraph. What is subgraph? So meaning of subgraph is same as you know about set and subset. You know what is subset? So if A and B are two set, then B is said to be subset if each element of B are in A. So similarly, if G is equal to VE is a graph, this is either directed or not, or undirected. Okay, so this is are directed or undirected. Then EH is equal to V dash E dash is called subgraph of G if V dash is less or equal to V is nothing but, in the case of set, V dash is subset of V and E dash is less or equal to E or E dash is subset of E. Okay, so this is very simple, like set and subset. Okay, so if G is equal to V is a graph, then another graph H is equal to V dash E dash is called subgraph of G if V dash less or equal to V and E dash less or equal to E. For example, suppose this is a graph V1, V2, V3 and V4. Okay, so this graph have 4 vertices. This have 4 vertices. Okay, so suppose this G is equal to VE. Now there are so many subgraphs of this graph. So okay, so if this is also, so you see, if we drop this line, so a new graph means, suppose this is V1, V2, V3, V4 means V1, V2, V3, V4. So this is a subgraph of this, because in this graph this edge does not present. Okay, similarly there are so many subgraphs. So this is a subgraph. Similarly, if we take only this point, means this is a graph. So this is subgraph. This is H. Okay, and another, if we take only this and this and this, means this and this. So this is also a subgraph. Okay, so now I am going to explain walk. So this word walk is very familiar to each and everyone, because you have always used morning walk and evening walk. So what is the meaning of morning walk? So you start walk from your home, and this is road. So you get these points, again road, this point, again road, and you return your home. Okay, so this is called morning walk or evening walk. So in a similar fashion, I am going to explain in our mathematics. Okay, so these are points, means these are vertices. Okay, these are edges, vertices, edge, vertices, edge. So what is the definition? So a walk is a finite sequence of vertices, edges, vertices, edges, vertices, edges. Okay, vertices and edges, that is V0, E1, this is V0, E1, V1, E2, V2, E3, V4, this type. Okay, so V0, E1, V1, E2, V2, E3 up to this type. It means Vn minus 1 En. So this is very easy to explain walk. A walk is a finite sequence of vertices and edges is called walk. So also the type of walk. So if you start journey, means walk from your home, and you are happy, so you return in your home. Sometimes if you are angry, so you will not return your home, you will walk and walk. So there are two types of walks. One is closed walk. If you are happy, so you get closed walk, and if you are angry, so this is you have open walk. Okay, so type of walk. So I am going to explain very systematically, means in a summarized form, means walk. So in the walk, edge and vertices can be repeated. Okay. So now there are two types of walk. One is open walk and second is closed walk. Open walk and second is closed walk. Open walk means if initial vertex and terminal vertex are different. So this is open. It means if you start morning walk with your happiness, so you does not get open walk because you not return in your home. So this is not initial and terminal vertices are same. So this is open. If these are closed means if you start walk and return again, this point means in your home. So this is called closed walk. Okay. So there are two types of walks. Open walk means initial and terminal vertices are different. So initial and terminal vertices are different. In other words, initial and last vertices, okay, and closed walk, initial and terminal means these are same. Initial and terminal vertices means when you start from your walk and you end, so both are same. This is the open walk. So there are open walk and open walk in which no edge is repeated. Okay, so this is called trail. This is new definition of open walk. If in this case an open walk in which no edge repeated means no edge repeated. Okay, so this is called trail. And similarly in a closed walk, here no edge repeated, so this is called circuit, means no edge repeated. This is again, if vertices are not repeated in trail, so this is called path. It means no vertices repeated. So this is called path. And similarly in a circuit, if no vertices repeated, so this is called cycle. Okay, means no vertices repeated. Okay, so this is the basic summary about graph walk. Okay, so in a walk, you know, finite sequence of vertices, edges, vertices, edges, vertices, edges. Okay, so there are two types of walk, open walk and closed walk. In open walk, initial vertex and last means when you start from V0 and end from Vn, so if V0 and Vn are different, then this is open. And if V0 and Vn are same, this is closed walk. Okay, in open walk, if edge is not repeated, then this is called trail. In closed walk, edge is not repeated, then this is called circuit. Again, if open walk, no vertices repeated, means a trail is called path if vertices not repeated. So this is called path. In a similar case, in circuit, if no vertices repeated, so this is called cycle. Okay, so these are the definition of different keywords in a walk. Okay, so this is definition of walk. Also, what is the length of walk? So you see, length of walk, length of walk. Length of walk means number of edges in a walk. So you noted that number of edges in a walk is called length of walk. Like if here you have used this is a walk, means V0, V1, V1, V2, V2, V3. So how many edges? 1, 2, 3. So length of this walk is 3. Connected and disconnected graph. So this is very clear to name of connected. Okay. So an undirected graph is said to be connected if there is a path between every two vertices, between every two vertices. Okay, means between two vertices at least one edge. So this is called connected. Otherwise it is called connected. Okay, otherwise it is said to be disconnected. So this is very clear. Connected and disconnected means if you start from here V0 or V1, so V2, V3, so this start from V1, V2, V3 and here V4. Okay, so this is connected, or this is path between V3 to V4 or V5 or this thing V6, means here this is connected, means between V1 to V2 there is a path, V2 to V0 this is a path. So this is connected graph. Okay, but if you see this is one graph, means V1, V2 and V3, and this is another graph, V1, V2 dash, V1 dash and V3 dash. So these are disconnected. So this is disconnected. Okay, disconnected. So this graph and this graph are called disconnected, but this is connected. Okay, so what is the definition? An undirected graph is said to be connected if there is a path between every two vertices. Okay, between this and this, this and this, this and this, there is a path. But here this is this is one graph and this is another. So this is disconnected because between this and this no any path. Okay, so this is the basic definitions of connected and disconnected graph. Okay.